All right, can you hear me all right?
Yes.
Okay. Well, my name is Wright, and I'm here to talk about OpenStack as a starting point to running OpenShift. So to begin with, obligatory polling of the room. Who here is familiar? Who's an OpenStack? Stack?
I know what it is.
Oh man, this is going to be a really boring talk then. And I apologize in advance. So that boring in the sense that you're already going to know what I have to say. And here's the agenda. I'd like to start out by saying the agenda is actually a lie. What I'm going to go through is talking about OpenStack kind of from an architectural point of view, and we have great aspirations to doing a couple of demos, and we're actually too chicken to do them. That's maybe wise because we've done it before and had real problems with the networking component. So instead, we're going to kind of pre-can it and give you a fake live demo. So I will move right along, and of course, in these, feel free to ask questions. It's more enjoyable for everybody, and the idea here is to give you some sense of OpenStack, and feel free to ask questions, and then we'll look at how one of the interesting pieces of OpenStack provide as an infrastructure for running OpenShift. So, what is OpenStack? I think from a very high level point of view, it's the infrastructure services required to run your own cloud. There's a long list of particular services here. You can imagine all of the things you might need to run a cloud. You need to be able to manage compute resources, storage resources, networking resources. So what I've got here is a list of the specific projects and the resources that they provide. The first one is probably the most well-known from OpenStack, and that's Nova. Nova provides compute. Typically it's virtualization, although not always. We have a block storage project, which has recently been split out from Nova and turned into a standalone project called Cinder, and that's where you would do persistent storage of data. Those block storage devices show up as block devices in your virtual machines. Next we have Quantum, which is a network service. Again, something that originally started in Nova. Over time, the core networking functionality in Nova was fairly simplistic, and that the goal of Quantum is to provide more advanced networking capabilities from a single new service. We have Glance, which is an image service. Swift, which I'm not actually going to talk about much here. It's an object storage service similar to S3 and Amazon. An identity service, which is sort of central to this whole mechanism, called Keystone, and a dashboard UI called Horizon. The names on the right are the kind of project code names. On the left is the functionality. What I'm really talking about here is the OpenStack fulsome release. And the reason I'm talking about that is because that's what's available on Fedora, and that's what's available on RHEL through the Red Hat OpenStack product. And we just, this is the Havana OpenStack Summit starting tomorrow, which means the Grizzly release has been released, but the packages in the distros haven't quite been completely updated, so we're a little bit out of date. But I'm going to skip completely ahead the very bottom here to the Havana release, which is roughly 6 months from now. And there are two new projects coming. One is providing infrastructure for monitoring and metering. And that would be the primary place where something like billing systems could go and get detailed information about life cycle events, so you can figure out how much resources a tenant is using. And then an orchestration system called Heat. And Heat is actually going to get some airtime in this presentation because it's one of the interesting and cool ways that we're using OpenShift and OpenStack together. So just kind of a pictorial view of all of those services minus the two new ones. At the top, there's a dashboard. The dashboard has the ability to talk to each of these individual services, typically just through a public-facing REST API. And then at the bottom there, you see the identity component, and it's sort of the substrate. Everything is talking to the identity service, and in fact, even the UI has the ability to talk to the identity service. So we will go there first. The identity service is at a very high level, it's giving you the tools to manage users, tenants, applying roles so that you can do role-based access control. Internally, it has a few different services. A token service, so a typical transaction with the identity service would be you give it some credentials, you give back a token. Now that token is a valid way to identify yourself to all of the other services that you're talking to and show that you are in fact a legitimate user of the system. It has a mechanism for registering policy. So each of the services that run in OpenStack have essentially a policy file that tries to identify the types of actions that can be taken and the authorization required to take those actions. So you, as a service, you load your policy to the Keystone Identity Service, and that's a way to sort of centrally combine the policies. Similarly, as a service, you register with the identity service, and then as a user, you can get a service catalog of the services that are available to you. So you log in, you give your credentials, you get back not only a token, but also potentially a full service catalog of what the service endpoints are and what the services are that are available in the system. The identity service, like many of the OpenStack services, are designed to be pluggable. So there's a short list of plugins here, or pluggable backends here. And the first one is a key value store. I think the second one is SQL backends. You could do PAM, or you could integrate to LDAP, or looking at some directory-based user system. The goal there is to give you a number of different ways to integrate Keystone into your environment. Something like the key value stores in memory, and that's usually done more for testing. SQL is a pretty common one for small deployments, and then if you have pre-existing infrastructure, you might be using something like LDAP. The identity service, from a kind of architectural point of view, looks like this. At the top, you have the REST API. This is what users, this is public-facing, what users are hitting. And then internally, you have some additional services, a token service, an identity service, the policy and catalog services that are providing all that functionality that I was talking about earlier. This is kind of a typical template for how OpenStack services are built. There's some REST-facing, public-facing REST API, a set of services that are backing that, and each of which typically are pluggable so that you can uniquely create a deployment that fits your requirements and fits into your infrastructure. OpenStack Compute, also known as Nova. The list here is sort of arbitrary of the things that it can do. It's hard to do an exhaustive list of everything that Nova does. It really is sort of the core, and definitely historically, it's a big piece of what launched the OpenStack project. It's multi-tenant, so that's a pretty core piece of the puzzle here. You really couldn't be a cloud solution if you're not multi-tenant. It's highly scalable, so the another kind of common paradigm used in OpenStack is the front ends are RESTful. They are you could easily horizontally scale them by adding more and more front ends and placing a load balancer in front of them. And then internally, services are listening on a bus, and services that need to scale internally, you just add more services, and they're pulling messages off the bus in parallel with one another. And then the core state is kept in the database. So it's a highly scalable system. You can, we haven't done the top-end scaling testing to really know where it starts to fall down, but architecturally we understand and we're confident that it's definitely a very scalable system. And actually, it would be great to hear if anybody here, is anybody deploying OpenStack? We got 3.5 people deploying. Oh, 3 and 2 halves, so 4 people. At what scale are these like all in one on your laptop?
I put Nova on a workstation about 9 months ago, and I don't remember. Basically, it was too complicated for me.
Well, I can relate to that.
Well, I don't have enough RAM either. The thing only has 4 gig.
Yeah. So There may be hardware limitations for each individual node, but the system architecturally can scale. It's not uncommon for people to try to use OpenStack and find that it's really complicated and difficult to set up. What we would have demoed is how easy it is to set up, but again, we're two children, so I apologize. But we're building tools as the project matures. We're building tools to make it easier and easier to actually deploy the system. And one interesting statistic that I recall is a fully deployed system has roughly, I think, somewhere in the realm of 1,000 to 1,200 configuration variables, and we have a wrapper script around that that allows you to boil that down to more on the order of 10. So it's a pretty significant reduction of complexity just by wrapping this and providing some intelligent defaults. Anyway, that's a digression. Nova Compute has support for a lot of different hypervisors. So you see a long list here. This is these are actually not all hypervisors. First of all, you notice the far right there is bare metal. So there is the capability to run application workloads on bare metal servers. Typically, people are using virtualization, and KVM, Zen, and even Linux containers all can be managed with libvirt. Zen can also be managed natively with the Zen API driver. And then there's a VMware API driver to work with VMware vSphere, and there's a Hyper-V driver as well. So, and recently IBM contributed a Power VM driver. So these are all the different virt drivers. In most deployments, you're not seeing a heterogeneous set of hypervisors. While the system supports different hypervisors, most deployments right now are sticking to a single hypervisor. The Nova Compute API is presented to the user as both a native OpenStack REST API and then an EC2 API, EC2 compatible API. Those are both native to the project itself. The EC2 API is not quite doesn't have quite the same functionality as the OpenStack API, and at each of the design summits there's different arguments about how long the project wants to continue to support natively different interfaces like EC2. To date, it's still in the OpenStack code base, and because of its history, I think there's a reasonable chance that it'll stay there. But stay tuned and go to the OpenStack Design Summit this week and find out for yourself. The final thing I have here is some basic ideas that Nova exposes: instances, flavors, images, volumes, floating IPs, key pairs, security groups. These are all things that are either completely familiar to you because you've been doing cloud computing for a long time, or they sound strange because you're coming either from a background of virtualization applied to enterprise data centers, or you don't have a virtualization background at all. Instances are running VMs, essentially. Flavors are descriptions of the virtual hardware that is running the VM. An image is the content that you're running in the VM. Volumes, I mentioned earlier, that's the block devices that can be associated with VMs and allow for persistent storage, because images are typically ephemeral. So you boot an image, you grab an image from an image repository, you run the image, any modifications made to the image during runtime are lost as soon as that image is shut down. So you need a place to do persistent storage. Floating IPs are a way to give you a dynamic way to allocate public-facing IP addresses associated with your workloads. As a tenant, you may be only allocating an internal private network, and you still need to have a way to publicly access your workloads. Key pairs gives you just a simple way to upload your credentials to an instance, and then the public portion. And security groups is a form of firewalling, typically used in the context of floating IPs. And this is the block diagram associated with Nova Compute. At the top, again, you see the REST APIs, or also in parallel the EC2 APIs. In the center, you see a message bus and a database. That's kind of a logical view. It's not necessarily, it doesn't have to be deployed on the same box. On the right-hand side of the picture here, you see a set of schedulers, and down at the bottom, you see a set of compute nodes. The compute nodes, in this case, are using the libvirt virt driver to talk to KVM instance on each of the hypervisors. You also see a little box labeled network. The network here could be either provided by Nova or provided by Quantum. That depends on how you configured and deployed your system. The interesting thing to see here is the top, it scales out with multiple API servers, and then as you're launching new VMs and you need to figure out where to put those VMs, the scheduling, the request to do scheduling could potentially be expensive, and if you need to scale that, you can just simply add schedulers and they'll pull the scheduling to do run instance request off of the message queue and process them each in parallel.
Just a question, is there a
Yes.
particular reason why you're using Qubit instead of Rabbit?
So the question is, why Qubit instead of Rabbit? That's really a historical question for Red Hat specifically. This is generically AMQP. We're deploying as a default with Qubit because we have a lot of expertise. We've been working with AMQP as a standard, and Qubit is really a project that's coming from Red Hat. So RabbitMQ, Erlang creates a whole set of other dependencies. It's not something that we have quite the same expertise with, so we typically deploy Qubit, but that's not a hard requirement, it's just our recommendation. The image service, this gives you the ability to essentially register images with the system and then pull those images back when you want to go launch an instance. You can back the image service with a number of different storage mechanisms. Swift, the object storage, S3, you have file systems. RDD is new to Folsom, and coming in a later release, you'll see Gluster support as well for distributed block storage. Technically, it supports a number of different image types and container types. The container types are sort of fake. They're not always used properly, so the fact that you can upload an image that's called an OVF image doesn't necessarily mean it's handled as an OVF image. It's just a sort of metadata tag associated with it right now. But all of these pieces are supported. The most typical one that we find in the KVM context is QTOP2. Let's see. And when you pull, the images are stored essentially external from the hypervisors. When you go to launch an instance, you have to pull the image onto the hypervisor, and that image can be cached there. Images can be made public or private. Public images are available to everybody. Private images you can extend or contract how private it is by adding membership associated with private images. This is a much simpler service. It looks roughly like this. API, registry is sort of the mapping of the image to its location, and then the database is storing all the information. The block storage service, which is called codenamed Cinder, that was recently broken out of Nova, and it really literally was an actual copy of the code, and since it's been copied, it's been modified and improved. The main changes really have been in adding additional backends to Cinder. It gives you persistent storage. It gives you the ability to create volumes, snapshot volumes. The management of how you attach a volume to a running instance or launch an instance with a volume is done through the compute side. So that's Nova saying, over in Cinder, I've created a volume, and in Nova, I'd like to attach that volume to a running instance. I have a long list of the different storage backends here, but needless to say, it's a place where storage vendors can come and rally around. How do I provide my snapshotting functionality natively through some REST API that's specific to my storage area network or NAS box? This is the integration point for those vendors, and we're starting to see a lot of traction in the OpenStack community with new drivers, and it's an area that Red Hat cares about because we have a lot of these are historically our partners. We're in the enterprise, non-virtualized world, we're still needing to get access to these same storage devices. So for us, this is really cool area. We're excited about it here.
Gluster is a part of it?
The
Long drivers, storage drivers?
currently no. There's future plans there. Yeah. So if you look in the later releases, you'll see work to do cluster support. But right now, this is limited to the Folsom release, which is technically already 6 months old. So in OpenStack timeframe, that's nearly an ice age. you can see the similarity to the compute block diagram because it was literally taken from compute. The difference here is down at the bottom. These are essentially volume managers, and what they're sitting in is a little bit opaque, and it's not always a one-to-one correspondence between the volume manager and the device that it's sitting on. In some cases, it's a proxy talking to something like a storage array. But it's got the same basic design, same scheduler to figure out where to place your create me a volume request or serve that create me a volume request from, and so similar scaling principles. The networking service, again, you can get some node-native networking, but it's fairly limited. The newer networking service is currently called codename Quantum, but that name is subject to change due to some concerns about trademarks. What it's really doing right now is giving you the ability to manage layer 2 broadcast domains, which are in quantum parlance called networks. IP address ranges associated with those layer 2 broadcast domains, which in quantum are referred to as subnets, and then ports, which are attachment points into these networks. So that's where your virtual machine's tap device is plugged into the network, or in some cases, if you're connecting two L2 segments together through like a router device, those may be the ports that are not necessarily from a VM, but attaching to either side of those two networks. The Quantum API, it started off very simple with just giving an L2 broadcast domain. It's moved forward a little bit, and one of the mechanisms it uses to move forward is we add extensions first, we check them out, we try them out, we see how they work, and as they get time proven, then those extensions potentially become part of the newer APIs. Currently, there are extensions for L3 properties, routers, floating IP addresses, the ability to SNAT or DNAT depending on if you're associating an IP or just trying to get access to a public network. And then this thing called provider networks, which is very useful in an enterprise context where you're coming into a pre-provisioned network and you need to attach your cloud, some of your cloud application workloads to, say, VLAN 100. It's a well-known entity within your data center, and it's already got meaning. Typically, the VLAN or segmentation IDs are allocated dynamically, have no external meaning. They're just a way to do internally to do tenant segmentation. Provider networks gives you the ability to kind of override and directly attach your applications to specific portions of your network. Here's a long list of the different plugins associated with Quantum. Initially, it was really just about Open vSwitch. Subsequently, it's Linux Bridge, and those are two virtual switching technologies that are available in Linux. There's one called a meta plugin, which allows you to combine different plugins together and try to create a heterogeneous switching environment. And then the rest of these, the Cisco, the NEC, the NVP, and the Ryu plugins are requiring some external agent, often an SDN controller. In the Cisco case, it's a piece of hardware. So the Linux Bridge and Open vSwitch don't necessarily have that same principle of your network requests are going to some centralized SDN controller that they're handled internally within the system. The others are requiring this external component. And to date, most of these are proprietary third-party products. We'll see that change. The industry is rallying around some attempts to create open source-based SDN controllers. And of course, we expect to see that well supported in OpenStack, especially Red Hat has a lot of interest in making that happen.
I think there is already actually a plugin for Open Daylight to stop that going on.
So the comment is there's already a Quantum plugin for Open Daylight, and that's a complicated comment. So it's an interesting discussion for later. It's not 100% accurate, but yes, there is an effort in place already to create a bridge between the recently announced Open Daylight consortium and Quantum's OpenStack's Quantum service. This is the pictorial view of Quantum. We have a Quantum server at the top, which has integrated together both the API service and then some of the server or engine functionality. You see, I have one path here, which is a REST/other interface to an external controller. the standard Cupid and database component. Down at the bottom are compute nodes. The compute nodes have plug-in agents, potentially, in the case of Linux Bridge or vSwitch plugins, and those plugin agents are talking directly with the plugin at the top of the picture. In the case of an external controller, they don't require a plugin agent. They typically are using OpenFlow to program the virtual switch instances on the hypervisor nodes. And then there's this external network controller node, which provides DHCP services and routing services for all the workloads in your network. That's how the picture looks right now. In the future, you'll see that network controller node being able to be spread across multiple physical boxes, so you can get a better use of your resources and better scaling, and not create that thing as a bottleneck for all of your network traffic. The next component here is heat. So this is a little bit forward-looking. To date, everything I've been talking about is Folsom specific. Heat has been an incubation project, and in the Havana release, we'll see it as an integrated project. It is, at a very high level, an orchestration system for launching instances. And in slightly more refined words, it's template-based, so if you're familiar at all with CloudFormation and the templates used in CloudFormation, it's really re-implementing that exact same infrastructure. With that template, you have the ability to simplify how you define launching your instances. So if you needed to go out and talk to a bunch of different services, allocate resources from all the different services in the infrastructure, figure out how to plug them together, that can be sort of complicated. Heat can sort of orchestrate all of that for you, and essentially it's a defined language that helps you build what would look like some complicated script that you were using to launch your own workloads. In addition, you can do multi-instance orchestration. So if there are situations where you want to launch an entire app, your app has multiple tiers, there's dependencies between those tiers saying, I need to know the network address from this tier in order to even get this tier started so that they can talk to each other. That kind of information can be encoded in the template. And then in addition, there's the ability to monitor some metrics associated with the workload, so you could do things like discover that a service has gone down and have heat restarted, or discover that your service is beyond some user-defined thresholds and you need to start auto-scaling your service. And this is an area where we expect that there's a great synergy between OpenShift and OpenStack. It has a couple of APIs similar to Nova, where there's because this is a project that started off implementing some AWS functionality, there's an AWS native interface, and then there's a more standard REST API for OpenStack. This is a pictorial view, and it's a fairly straightforward APIs at the top, AMQP, and then a number of heat engines pulling the requests off at the bottom, and then doing the orchestration required to launch the images. And then I have, thanks to one of the Heat developers, this awesome diagram, which is really showing you what Heat's doing for you. It's saying, instead of having to make all of these separate API calls yourself, Heat will just do that for you by you feeding it a template. So you can see up at the top, there's a template defining your workload. You feed that to Heat. You on the far left side, you can pre-populate the images with an image builder that's going to place some Heat agents inside an image. And then this is Heat talking to all the different services as the image is booting up, and you can see these CFN tools, init, hub, push stacks. These are tools that are allowing the running instance to talk to or receive information from the Heat orchestration system. And that's where you might be doing some of your metrics updating or polling, or finding out what information needs to pass back and forth between the instance of Heat, maybe for orchestrating the next part of your workload. I think that's it. And the only last thing here was just a quick view of the dashboard. I ran this on my laptop, so it's not very interesting, but and it's an eye chart, so you can't even read it. But basically, there's a web UI that allows you to go through and allocate all the resources that I described beforehand. You can do some monitoring, and the web UI is fairly modular, so if you're doing some modifications to your deployment, you can drop new content into the framework and get new flows through the UI. I think that's it. So, yeah, this is the big part of the agenda where we actually don't live demo. I'll break right there for questions. My goal is to stick to 30 minutes, and I'm at 30 minutes and 50 seconds, so you better have really short questions.
So do you guys have a plan on how far behind you trail between the releases of OpenStack?
You guys, I'm only one person
Me,
talking.
Red Hat.
Red Hat, okay.
Because I know,
The question is, how far is Red Hat planning to trail the upstream releases in productizing OpenStack? The answer is, we have a plan. It's a cunning plan. I can't tell now. Right now, the Folsom release is a full release cycle behind us, 6 months. So we're just doing a GA of the Folsom release or a limited availability release of Folsom from Red Hat. The Grizzly release, which is effectively out today, you'll see that in general availability from Red Hat in about 3 months. Our goal is to squeeze that a little bit less than 3 months. Getting much below 2 months is probably unrealistic. So if I were you, I would consider 2 to 3 month lag time from upstream release to downstream productization from Red Hat.
Fedora 19 is going to ship with Folsom?
Fedora 19 should ship with Grizzly. Folsom is already out, packages are there, Grizzly packages are all but done, like a PhD dissertation. Cat 19 is not released yet, so.
Yeah, I know.
So are you backporting any Grizzly bug fixes to your Folsom release?
So the other question is, are you backporting Grizzly bug fixes to the Folsom release? I like to say two things on that. One is, yes. The other is, this is a community day, so let's not make it about Red Hat products. But yeah, we'll do that, and mostly we're following the Folsom stable branches. But, any other questions? Okay, so Krishna is going to go through the fake live demo.
It's real live, it's just not live right now.
And it was live at one point in the past.
Live on tape.
Oh, Krishna's live.
I'm here, yes.
You like?
Krishna's live, and it's only 2 days dead.
Yeah, Krishna's live, and there's a demo, so I think it's qualified.
One second. Standard VGA output technical difficulties.
Looks like the rain is falling on the school.
Okay, so OpenShift you can deploy on OpenStack using the Heat API. This you can do today. This demo is based on a Fedora 17 install of the Folsom release. And since Heat is not part of Folsom, there are a couple of extra services that you have to start out. If you walk through the Heat getting started guide, this is actually really cool because they have a single command in here to actually get everything installed. There's mouse.
Oh, use the
The link.
yeah. I disabled the trackpad because I was able for my thumb.
Right. So once you check out the Heat repository, there's a script in there called tools OpenStack. You can use that to install and start OpenStack. But since I had a couple of extra things to do, I actually created a little script which adds a couple of IP tables rules that are needed by CloudWatch. starts both OpenStack and the Heat APIs. There are 3 services that you need to start there. I'll put this video out on web so you don't have it. There's also 2 choices, or actually a couple of different choices that you can make for the demo when you're choosing networking. The one I've gone with is the VLAN network, and I've just copied the snippets that you need to put in the Nova conf file. Right, so if you choose to go with flat TCP, that's top one, or you can go with the bottom one. And that just lets you choose whatever networking you want. But in this case, I've gone with VLAN since it was simple. The one thing you would note is if you're running on a laptop, this will not work with the WLAN interface. There is no way to get WLAN into a bridge. So, and I spent quite a bit of time wasted on that. So this
everybody has. There are lies you can tell the MAC address to make it work, but not in a coffee
It's
house.
easier to just plug in an Ethernet and go with that. That works just fine. So after you get it started, it's going to start a couple of different services, and I will also source in the Keystone RC file, and that just loads up all of the credentials in the shell so that I can invoke Heat API. Fast forward a little here. So after everything is up and running, Heat API is running as well. The first thing you would need to do is compile 2 images. You need a broker image and a node image. And that is just taking the OpenStack Heat CFN template, which has a couple of plugins inside the image, and adding all of the packages, RPMs that are required by OpenShift. You can run this with just the basic Heat CFN template, but it'll just take half an hour to boot up every image. So much easier if you just pre-build your images. This takes a while, so you do this once, and that's time saved every time you boot up an image.
Can you say that again? What were you saying about the images?
Right, so when you boot up something with the Heat API, there is a Heat CFN template image, there's one for every operating system. And that has certain plugins necessary so that it can coordinate with Heat. So you can, correct me if I'm wrong.
Yeah, so basically we have a minimal operating system image, and for some functionality which Heat provides, you need some instance agents, as Chris mentioned in his presentation earlier on. And so we've just got a utility script which it simplifies building that image. It uses Oz behind the scene. You could do it manually if you wanted, or directly using Oz or using one of the other image building solutions out there. But this is just the development tool which we use. And so, as Krishna is saying, in order to speed up the speed of the stack launch, OpenShift has got a whole load of stuff that you need in order to make it work. And so you can front load some of that time by just doing it once and building it into baking. You bake it into your image, then you just do the customization specific to OpenShift when you do the stack.
There's a script that will do the heat parts and open parts.
Yeah, so basically we've got some Oz TDLs which allow you to define everything you're going to need.
So if you see up top here, I actually specify that it needs to create a x86 OpenShift Origin. And that's a template that there's a pull request outstanding against Heat JEOS. But that includes the templates needed by the broker as well as the node. So once you do this, it will spit out a QCOW2 image, and you need to add that to Glance so that the Heat API can spin up something using this. Conveniently, that command is right at the bottom. So just copy paste that in again, and that will add it to the Glance. So then you can go into the OpenShift UI, take a look at what images are available, and you will see all 3. So these are the 2 that I created. That was the basic CFN tools that was available. So the next thing you would do is actually spin up the stack. This is the heap command that you issue. It tells it, create me an OpenStack template and OpenShift template. And that includes all of the instructions to spin up the broker, spin up the node, and then connect it to it. There are a couple of parameters that are being passed in there. The first one is the key name, that is the SSH key that you can use to connect to the instances. The DNSSEC key, this is since the OpenShift broker connects to an internal DNS server, this is the key for them to talk to each other. And the last one is upstream DNS. So if the node needs to connect to an external service to download gems or Maven files, things like that, this is how it will resolve. So you issue the command, and that's just going to spin up, send off that request. You can then look at heap CFN list, and that tells you there's a creation in progress. You can pull this till it is complete. And if you actually look at what's going on while so it's going to spin up the broker, wait for the broker to be up completely. That then triggers the node to go next. And after everything is done, it will list the stack is completed. So the next thing I do is basically go to the host machine that's running all of these things and edit the name server. So I'm just pointing the host machine to use the broker as the DNS server. What this allows me to do is that once I have an application running within OpenShift, I can resolve this from the OpenStack host machine. In this particular case, the broker machine is running the broker itself, Mongo, the DNS server, and it basically has mcollective to talk to the nodes. And the web console as well. So after I do that, I can then go to the broker machine. By default, the template names the broker as the instance name.example.com. So you just browse to that. The default passwords, username, admin, password, and all of this is configurable. These are the defaults. And that pulls up the OpenShift console. This is the standard OpenShift Origin console that's distributed. And using this is basically the open source version of the website. So the website that Bill showed you earlier lets you spin up things using the web console. This is the open source version.
Someone had a question about the console shipping coming in.
Yeah, I remember you have like a lot of monitoring stuff and things like that in the initial version of OpenShift.
Yes.
You know how that is going to be with?
So we took that out because that wasn't really adequate with what we wanted to do. So we'll be putting all of that back in, and we're hoping to get some community contribution around that as well.
Yeah, I remember the old version was like flat or something,
So that was actually a completely different product. That was Flex. That was a product that came in with the acquisition from Car. And we took a lot of the technology from that, as well as technology that Red Hat was building internally, and made OpenShift. It's a combination of the two.
what will it be adding like similar capabilities with that, like
We are looking at that, but that's still on the backlog.
It's Trello cards on there.
Yeah.
That's just another opportunity to contribute.
Right, so in this particular case, I'd chosen to spin up a WordPress template within OpenShift. And that spins up both a PHP cartridge as well as MySQL embedded. So it's a single command, does both. And it gives you the details to connect to MySQL if you wish to do that, but in this case it's WordPress, don't need to. So you can just directly hop onto the website that was just launched. So you can do the same thing from command line. The first thing you would do is install the RHC gem. These are the command line tools. The next step is to configure the command line tools to talk to the broker that we just spun up. You do that by running RHC setup and pass server as a parameter, and you tell it where to go. This will log you in. It will set up your SSH key. It will set up a token so that you don't have to type your password in every time, or you could pass it in, but you don't have to anymore. So I spun up WordPress already on the website. It recognizes that and just tells you. And then the commands to actually start an application are pretty much the same as the website. I think at this point, in the video I go and change about the same thing, OpenShift on OpenStack, and push that, and that's how that's yeah. So in this case, it's a PHP app, so the push is really quick.
Yeah.
We need to set it to music.
So I'm just showing the before and after over here. This is before the push, and after the push will just be updated. There we go. So that's OpenShift on OpenStack. The whole process end to end, starting with having to compile the images and heat API and all of that, takes about an hour depending on your network connection, just because it's pulling down a lot of RPMs. Yeah, I read it. Everything's online. Yeah.
Okay, so what, you're doing it not live. What has gone wrong in the live thing that caused you to not do it live?
So the live thing is the WLAN config. They don't have Ethernet here, so I can't actually plug in to go online. And although I've compiled the image and it has all of the RPMs installed, Yum requires you to go and at least pull down repository metadata so that it can run updates and things like that. And that requires the internet. So without the internet, I can't, you know, I can start the machine, it'll just sit there waiting for Yum to pull down metadata. But I have the laptop right here. You know, that I ran this last night and recorded it just because I knew this might happen. The laptop's right here. If I can get Ethernet up and running on here, then I'll do the demo live.
And we will have the hackathon from 5 to 9 with beer and pizza. So if you really want to try and do it live, they'll do it this evening over beer. You had a question?
Yeah, I have a question. So, OpenShift is on the OpenStack, and somebody mentioned that it's also backed by EC2.
Right, so OpenShift doesn't actually require any of the infrastructure services under it. All it requires is either RHEL or Fedora. You can run that on bare metal, you can run that on EC2, on OpenStack, doesn't matter to us. As long as you have RHEL or Fedora, you can install OpenShift on top, and if the broker can talk to the node, you're all set.
Do you know if there's any other Linuxes that are capable of running OpenShift? I heard Gentoo was possible.
Gentoo might be possible. They have SE Linux support, but in that case,
Stack.
OpenShift on OpenStack? Because there's different OpenStack implementations by different Linux vendors.
Because OpenSUSE and Ubuntu both have OpenStack.
But do they have the SE Linux
So
extensions? That's
you
one
don't
of
need, you don't need SE Linux to be on the machines that run OpenStack.
Okay.
Right? It's just the images that OpenShift is installed on, that needs SE Linux. It would be nice to have it on the whole thing, so that you have a fully secure installation. But just OpenShift is the only part that requires it. So I've heard that Gentoo actually has an SE Linux.
Gentoo, Suzy, and Ubuntu has as
So
I don't know if they've
just,
done, I don't know if anybody's made OpenShift work on top.
not yet, and I think that's just a matter of quoting the policies from.
Just getting the
Fedora.
policy of it around. Shouldn't be that difficult.
Sorry, I don't want to sideline the conversation. I think I think the point is for me that Red Hat's trying to go for anything that's OpenStack compliant if they have the right dependencies.
Yep. Any other questions?
Thank you.
Same great command line tools works on this as on OpenShift Online, right?
Yes, the same ones. I think the one that Bill displayed or showed earlier was an older version of the command line tools. So.
It is. It's a newer version. Bill is old. My fingers just don't change, right? I've been typing those things 5 billion times for a year and a half, so I'm not going to think about it.
That's actually a good point. We maintain backward compatibility up to like X number of releases of the client tools. So even if you have an old outdated version, like we actually test the REST API to make sure it's compliant with older tools.
Cool. All right. So without further ado, thanks.